Good morning students, welcome to and continuation of network problems with the help of Kirchhoff's current laws and voltage laws. As we know that practice makes perfect. In previous classes we known basic things in a networks, what is the node, what is the branch, what is the loop, what are the active elements, what are the passive elements, what is the active circuit, what is the passive circuit. We have completed few problems based on Ohm's law. If network becomes complex, then we are unable to solve simple networks with the help of Ohm's law. Then we are going to advanced technique, that is Kirchhoff laws. We have already learnt Kirchhoff current law, Kirchhoff voltage law, definitions, meaning, and we have completed few problems based on these two laws. And any electrical network can be solved with help of this KCL and KVL in three methods. One is the branch current method, second one is loop current method, third one is the nodal analysis method. In previous classes we have practiced n number of problems based on branch current method and loop current method also completed. Now the remaining is a nodal analysis. In this case we are going to apply KCL, Kirchhoff voltage law. What is the law? It defines that algebraic sum of currents entering into a node equal to 0, or we can say sum of the current entering into the node equal to the sum of the current leaving from that node. So based on this concept we are going to do the problems in nodal analysis. So nodal analysis, the voltage based theorem. So nodes we considered. Based on the nodes we are going to calculate what is the voltage at that nodes. Now let us see in details these theorems. So before going to our new technique, nodal analysis, just recall what we have seen in branch current method. Here the branch current method, as you know that, for example, there is a one source connected one resistance and connected another resistance, connected another source and is connected. For example, this is a one circuit. Let us assume here this is called E1, this is called U2, and the resistance in the circuit represented, this is called R1, R2 and R3. Let us assume the terminals, assume this is equal to A, B, C, D, E, F. Arbitrarily we are assuming. Now let us do the first case. So we have seen branch current method. First case, branch current method. In this case, what we have seen, in branch current method, we are assuming the current is flowing from this is equal to I1. The I1 current is flowing here, entering is I1. From this is we are assumed as I2 current, and the current is coming, and the current is flowing here. So the current across the BE is represented as a I1 plus I2 currents. So that means branch current A to B I1, branch B to E I1 plus I2, branch C to B I2 current. So here we are got two unknowns I1, I2. So two equations we can write it, branch method. So we are going to solve two equations for the two unknowns. So we are going to get I1, I2. This is a branch current method. Okay. In loop current method, so same in this case, loop current method, you take it, same circuit. Now same source is taken, resistance connected, resistance connected, resistance connected, source is connected, and here connected this one, and here connected this one. Okay. So similarly we represented A, B, C, D, E, F current. Okay. So this is called E1 current, this is called E2 current. Resistance R1, R2, R3, similar to the previous one. Now in loop current method, now what is the loop method? Closed loop. In this case we are assuming that loop current method. So here assumed one loop here, this one the loop is clockwise, taken the currents flowing I1 you are assuming. In this we are assuming this is the current is the I2, both are clockwise direction. Okay. Now here logic is that the current which is flowing from A to B is the I1, but B to E the current is flowing from the I1 downwards, I2 upwards. While writing the considering the loop from A, B, E, F, A, then you have to take it I1 minus I2. While considering B, C, D, E, B loop, then the current you have to observe, write the equation branch BE, EB, then you have to take it I2 minus I1 into R2. These are the two techniques you should remember. So we have done the 2-3 problems in previous class. This is known as the loop current method. Loop current method, just logic. So where the two currents are competition, for example, we taken the example previously, this is a Telangana, this is a Rayalaseema. So in between two areas, while in Telangana you have to consider the preference first I1 minus I2, while in I2 in Andhra, then you take the I2 minus I1, you take the wherever the common current element through which two currents flowing. If you remember that logic, so you can write equations by seeing itself. You can do the simple problems by using the Cramer's rule. Okay. Now here the two equations, two unknowns, we can write it. Now let us do the another method is a nodal analysis. Okay. So we will see nodal analysis now. Now you take the one equation. What the equation? You take it similar to the nodal analysis. already we have covered in first and second problem also. Same problem I am taking here. Now, so from here I am taking the source, then resistance, from here resistance, source, resistance, resistance, resistance. Okay. Now here we connect the one resistance, source here. Previously we considered the same problem. The 5 volts, 5 volts, here is the 10 volts. Each resistance value 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm previously. Now the same problem we are going to solve with help of the nodal analysis. So nodes we are going to take it. Now consider the terminals. Same, this is a A, this is a B, C, D, and this is the E last. Okay. So now considering the nodal analysis, so we are going to do the equations. Okay. So you apply the nodal voltages. Here you can see it at A terminal. You can see the what is the current. For example, the current is flowing this direction, and entering this direction. At node A, here you can see the currents. A is entering, branch AB is flowing this direction, and AD is current flowing this direction. Then write the equation at A. So next at the B junction, after receiving the B junction, the current is entering here, some of the current is going here and some of the current is leaving here. Same, you are going to apply the KCL. Now at D also current coming and leaving, apply the node here also. And in this case, what is the current coming and leaving, apply this one. At nodes, we are going to apply the nodal analysis, we are going to write the equations. In this case, you have to remember that one of the common node taken as a reference, or you can say the datum node. So by making the one node as a reference, remaining nodes are sizes decreases, then we are going to calculate easily. I think this problem is somewhat complicated. First we will do the simple problem. After that we will come to here. Okay. So this concept is same thing. Then we will do the same problem later. Before going to this complex network, we are going to the simple problem for understanding purpose. After that we are going to do this one. Okay. So let us see another problem. Now we take it the previous what we have seen previous problem in loop analysis. Take this is the resistance and here is the resistance. Here take the resistance, now resistance. Now we connected the source. Here bottom terms we connected the common point. Okay. So what we have seen, this is equal to E1, this is equal to E2. Okay. Now we assume that this is R1, R2, R3, R4, R5. Loop analysis we have done. Now in this case, small observations you have to remember that how many nodes mainly here. Here you can see it. The current flowing this branch, from this branch the same current is flowing, same current is flowing, yet same current is flowing. So how many number of branches? So previously we calculated meshes, 3 meshes. Nodes we taken as a, how many nodes? We taken the 2 nodes. Here you can see, for example, you take the node, this is equal to A, it taken as the node is equal to B, and taken this is equal to another, you take the C, you take the C. Now A, B, C, 3 nodes we taken here. Now the C nodes as taken as a reference value, From reference to A, what is the equations? Some reference to B, what is the equations? You are going to write it. That means from A to C and B to C, you are going to write the equations. So from this one, we are going to write the 2 equations, we are going to get it. So here 3 unknowns. That means at what is the voltage at VA at node A, what is the voltage at node B. So if you know the VA, VB, so we are going to get that all values, currents, everything we are going to get it, because C is the reference taken. Okay, so this is the basic circuit. Once again you remember that. So you taken the common nodes. Here, this is the one branch, same current is flowing, So what is the KCL? Sum of the current entering equal to the sum of current leaving. Same here, B is the sum of the current leaving and sum. So in between, and C is another node. Now this is a one node forcefully make as a reference. With reference to this node, what is the current or what is the voltage across the VAC? We can say this is a voltage at node A, that is called VAC. What is the voltage across the B? That is the VBC. So here unknown voltage at A, voltage at B. If you know that, then what is the voltage? This by this we are going to get the what is the current here. If you know this value, so this voltage minus this voltage we are going to the this current here. If you know the B value, so this voltage minus this voltage, that is the resultant voltage, by what is the resistance, we are going to get that what is the current in the circuit. That is the basic idea. First you know the volt potential at common points. After that we are going to do the calculations. Okay, so let us write the few equations for this one. Okay, now you can see it. Okay, so you can write to the equations, small equations. Now at node A, you can apply in the KCL at node A. At node A terminals, this set. What is the current here? You can see R1 current, that is equal to, you take it, we can write it simply, instead of A, VA can write it, or you can write the V1, V2. Okay, let us raise the VA, or we can the node A is equal to, at node A that is equal to V1, at node B is equal to V2. V1, V2 are unknown values we are going to find in this problem. Then this is equal to V1, this is equal to V2. Now if you know the V1, if you know the E1, then V1 minus V1 by R2 we are going to the what is the current here. That is the concept. Apply the KCL. What is the current is flowing in the A, this branch, that is equal to, you can write it V1, this V1 minus E1, voltage divided by resistance R1, that is equal current flowing here. Now plus here, what is this one? V1 by R2, this is the current. Okay, now this current I required, plus I can write it V1 minus V2, that is a beat, divided by what is the resistance? Simple, common resistor R3, equal to 0. This is the equation, simple equation. Friends, see it. Here what we have written here, simple, remember that. Here what is happened? At B, at A terminal, current is flowing in this direction, current is flowing in this direction, current is flowing in this direction. We assumed at A, V1, here is the E1 is connected here, in between some resistance, in between resistance, here is a V2, another terminal, here is the C terminal, reference now. Now V1 minus E2, so here is a V1 minus E1, V1 minus E1 divided by this resistance. What is the resistance? R1. So we got this current plus this current I want to know. V1 reference, V1 by direct, what is the resistance? That is the value. Now I want this current, then V1 minus V2 divided by what is the resistance? R3. I written this one. This is a basic concept. Then you are going to simplify it. You are going to the one equation. Now similarly apply the at node B. At node B, what you are observing here? So here node B, so you can see here, this is the okay. What is the B? This is the V2, we can say B point. The current is coming here, current is going here, current is also going here. Okay. So here I connected some resistance and E2. Here some resistance and C terminal. Here I connected the some resistance into V1. So that means here what how this current, this current, this current, sum of the current from the node equal to 0. Then this is the resistance, this is the resistance, this is the resistance, this is the 0. So V2 minus E2 by R, we are going to get this value. V2 minus V1 by R, we are going to this current, okay, this current, and V2 by R3, we are going to this current. Just remember friends. Now what we are going to write it? Simply see it. Now so V1, this is V2, this is the resistance. I want to know the current here. So high potential to low potential, because we represented this direction. Then what is the, I am going to write it, this what is the current here? V2 minus V1 by R, this R current, R1 for example, this is the current value. Now what is the current here? This R2 for example. So that is equal to V2 by R2, we are going to get this current here. Now I want this current, for example R3. Then what is the value? So V2 minus V3 or E3, I can write it the E2 by R3, we are going to this current here. This current plus this current plus this current is equal to 0. That is the second equation. Okay, write it the equation. Similarly here, then we are going to write it. What is the equation? Second equation. So V2 minus V1 by, what is the value this one? R3, no? So R3 plus V2 by R4, this value, plus here V2 minus E2 divided by R5 equal to 0. This is the second equation. This is the first equation, this is the second equation. simple, make it the V1 terms, V2 terms and write in matrix form. Done. So, we are going to get these two equations here. So, what is the equation? We are going to get first equation, by if we simplifying that equation, we are going to get first equation, we are going to get that V1 into 1 minus R1 plus 1 minus R2 plus 1 minus R3, okay, minus V2 by R3 is equal to E1 by R1. This is the first equation simplification. We have written this equation. And coming to the second equation, we are going to get it, that is also nearly. So, we are going to get that is equal to V1 into minus 1 by R3 plus V2 into 1 by R3 plus 1 by R4 plus 1 by R5 into E2 by R5. This is the second equation. So, you can see here, from here we taken the from A and from B we written two equations. By simplifying these equations, so we are going to get two equations right in matrix form. So, what is the matrix form? Write it the matrix form. So, we are going to get this value, that is equal 1 by R1 plus 1 by R2 plus 1 by R3 first term minus 1 by R3 is a common term. Now, here same you are going to 1 by R3, next you are going to the 1 by R3 plus 1 by R4 plus 1 by R5, the second term closed. Then we are going to get, what is the value? Here V1, V2, that is equal to, we are going to get I1, I2 in terms of here E1 by R1 and E2 by R2. These are the terms. If you know the values of R1, R2, R3, simple substitute, then we are going to get that what is the V1 value, V2 value. If you know the V1 voltage across the A, V2 voltage across the B. If you know that, so we are going to calculate whatever we required. Okay. So, this is a small example. But in voltage nodal analysis, so 1 by R1, 1 by R2, 1 by R3, these are resistance values. Instead of 1 by R1, right, we can write the, so just you can write the G1. So, what is the inversely proportional of resistance? That is nothing but, so 1 by R is equal to conductance. Conductance can write it 1 by R1. Okay, write it the equation, because that is the simple calculation purpose. We are going to use the instead of resistance, we are going to write the conductance. So, here I am going to 1 by R1, I can write it. What is the equation? So, simple, 1 by R1 is equal G1 plus G2 plus G3 minus G3, here minus G3 here. So, G3 plus G4 plus G5. Okay. Then we are going to get same V1 and V2, that is equal to I1 I2. So, here what is the formula? So, here G is conductance, admittance, nothing but admittance. So, conductance into V, G into V is equal to I. So, here I we known and G we known, we are going to find the what is the voltage. So, we can say, so admittance matrix we can say. So, instead of this one G, we can the admittance, impedance. So, Z is equal to 1 by Y admittance, R is equal to 1 by G conductance. So, we converted into our required form. So, by solving these problems, we are going to get its V1 and V2. Very easy. This is a one method you can easily understand. Okay. So, shall we do the one example? Let us do it. A simple circuit, we can do the similar calculations. Okay. Then do it. Okay. So, dear students, so you remember this thing. Okay. So, here we take the simple problem. So, once again I am going to explain so you can see it. Simple problem. So, here what is happening? This is the simple circuit is given. Okay, I will draw once again. Okay, this is a 48 volts. This is equal to V1 we are assumed, this is a V2 we are assumed, this is taken as a reference. Okay, so this resistance 4 ohms, this is equal to 6 ohms, this is equal to 2 ohms, this is equal to 5 ohms. The current which is coming is a 8 amps. Now, simple apply our nodal analysis KCL at V1 and V2. Now, here unknown things are only so V1 and V2. If you know the V1, V2, we are going to calculate the current in any branch. That purpose, simple apply the KCL, sum of the current leaving from that nodes. For that purpose, we assumed that here the current is flowing this direction, the current is flowing this direction, the current is flowing this one. That is from junction V1, all currents are leaving. At the same time, V2 also current is leaving, current is leaving, current is leaving, such a way that we are assumed initially. Okay, then write the equations. So here V1, the current which is flowing 4 ohms, it is coming this direction current. The current is flowing this direction. The current is flowing this direction. First case. Based on this one, write the equations. Now, what is the equation? First equation. So here, first equation V1 minus 48 divided by, that is what is the resistance? 4 ohms. This current plus this current I required V1 by this resistance. V1 we don't know. What is the resistance? 6 ohms. Okay. Now another plus this current I required. Here V1 minus V2 by what is the resistance? 2 ohms. Okay. Now what we have written? So here this current, this current, this current, we taken the three equations. This is a one term, this is the another term, this is the another term you written here. Okay, then you simplify it, equal to what is the value? Now this value equal to 0. By rearranging the terms V1 and V2, so we are going to get equation simplification. What is the simplification? Then simplification, that is equal to 11 by 12 V1 minus V2 by 2 is equal to 12. This is the first equation at node A. Okay. Now coming to the V2. Write the same equations. Now coming to the same equation here, nodal 2, then at that condition, at this position, what is the current? Current or leaving this direction. What is that one? Here V2 minus V1, what is the resistance here? That is equal to 2 ohms plus this current, that is equal V2 by 5 ohms. Next this current plus, and this minus this, but current is coming reverse direction. So take the minus of 8 equal to 0. This term, this one, this term, this one, this term, this one directly is given the current. Then simplify the second equation also. By getting the simple equation, then minus V1 by 2 plus 7 by 10 V2 is equal to 8. This is a second equation. So here first equation we got it this value, and second equation we got it this value. Now, so based on this one, write in the matrix form. So write the matrix form. So simply writing the matrix form, we are going to get value that is equal to 11 by 12 minus 1 by 2 and minus 1 by 2, this is 7 by 10. So this is the equation. Then unknown V1, V2, that is equal to values. What is that? 12, 8. Simple matrix. You are very familiar to calculate the V1 and V2 because this is known, this known. Then we are going to get that by simplification. So what is the value? So by simplifying this one, you know this one calculations. Then we are going to get V1 is equal to 31.658 volts and V2 is equal to 34.658 volts. Sorry, 34 point, so nearly 34.04 volts. So two voltages we got it. Simply substitute the in equation. So we got it. This what is the value of here? Write it simply. Now write the simple equation values. Now here what is the V1? V1 is equal to, we are going to get, what is the value? We got it. So 31 volts, but here is the 48 volts. So we assume that current is flowing this direction, but how it is possible? So here a higher voltage or lower voltage, current has to move this direction. So we are going to get that the current is equal to 34 minus 48 by 4. We are going to get the negative value. That means we are assumed initial value is reversed. So you can change it. So we are going to get the current. Suppose I want the current this one. So 31 by this value. What is the current? 6. So we are going to the nearly 5 point something current. It's a positive value. So assumed is the correct value. So after knowing this one 31, this is the 34 amps. So we are going to calculate each branch current easily. These are the some methods of solving nodal analysis. Dear students, you practice it, more number of problems, you may get the idea, because these problems are very essential to understand in final year itself. In short transmission lines, long transmission lines, 5 method and T networks and vector diagrams you are going to calculate. If you know these networks, those subjects are very easy to understand. So try to solve these all problems. Then if you are facing any problems, just you ask me, I can help you. Okay, these are the concepts. Now you are observed how much time is taken to solve simple one method. Okay, the concept is this one, and based on this concept you practice remaining all problems. Okay, thank you for listening.